Hello, this is Miss Lindsay. Now we're going to tackle this word problem here in terms of a hyperbola. We have two listening stations located at the ordered pair 3300, 0 and negative 3300, 0 to monitor an explosion. The second station detects the explosion 4 seconds after the first. Assuming the coordinate system is measured in feet and that sound travels at 1,100 feet per second, determine an equation to represent the possible points of the explosion. So let's just visually draw this out in terms of a hyperbola. So if I have a hyperbola, we have listening stations at 3,300 as well as negative 3,300, 0, 0. Okay, so what we'll have here in this case, if you recall from what we've gone through with hyperbolas and with that PowerPoint, we've talked about how when you have a hyperbola, that the sounds are heard at the exact same time along that hyperbola. Well, what we have is we have some random explosion. I'll just mark that with that black X there, somewhere along the line. We do not know exactly where that is. I just picked a point. So what happens is at these listening stations, those are going to be our foci, we should be able to actually figure out when this all occurs, this equation, to help us represent where this explosion would then lie. Okay, so let's look at the next set of information here. So we have, in our case here, we have the second station detects here's the explosion 4 seconds after the first. Well, let's be a little bit more specific in terms of this. Let's call this one our first station, and we'll call this one our second station over here. Okay, so we can label a few different things in terms of this. We can say, we know the distance here from our center to our vertices is going to be A and A. We can call that distance between the vertices and the foci X. And let's explore this just a little bit. So I'm going to go to Sketchpad. So here we have a hyperbola, and then we have our foci marked. If you notice on here, I have this difference is marked here. Okay, so I can adjust that. I'm going to happen to leave it here very close to 8. And then I'm going to actually talk about what did we get with this difference here. Okay, so y is, if you notice over here, it says y is 2a equals equivalent to the difference. Well, if I take this point P and I drag it towards negative a, which is going to be my vertices, you can visualize this little portion from A to F2. If I could take that segment and flip it over here, that would be equivalent to this radii of this circle. So therefore, this difference, right, this blue portion here, again, if I could just cut this off and place it over here in this circle, that would be equivalent to 2a. That's going to help us with our problem over here. So we can actually figure out the distance from vertex to vertex, from this vertex to vertex, so this distance here, from vertex to vertex, is going to be 2a, right? Well, in our case here, it's going to be distance equals rate times time because we're talking about the explosion. We have the rate of sound travels at 1,100 feet per second and in 4 seconds. So 4,400 or 4,400 feet is going to be equivalent to our 2a. So again, we can figure out the distance between the two vertices by our 2a value. And again, now talking about the speed of sound, we're able to find that distance. Therefore, we get a to be 2,200. So filling in our equation, we do know it opens right and left. Therefore, x is going to be first. Y would be second. We're going to use our center as the origin. So minus 0, minus 0. And again, a squared is always first. So that will go underneath our x value. Now we just need to find b squared. Well, if you recall, we know the foci is situated at 3,300 300 feet. So that is our C value. C will be 3,300. So we'll do A squared plus B squared equals C squared. So we'll have 2,200 squared plus B squared equals 3,300 squared. And we should be able to calculate that. I'm going to go ahead and just use my calculator, plug that in, 3,300 squared, and subtract 2,200 squared. So I get a B squared value of 600, pardon me, I'm missing a decimal there. So let me, I'm sorry, 0. Should be 4 zeros there. So that will be my B squared value.